All right, so welcome back. Now we're going to take a look at stem cells. So first kind of line of thought here is that most cells in an adult organism, and yes, I'd consider all of you adult organisms, do not go through the cell cycle. So it's always, I don't know, kind of a misnomer. We always think that, oh, every cell's in the cell cycle at some point, and they're not. Most cells don't go through the cell cycle. So it's an L there, L then a T, multipotent. So again, most cells do not go through the cell cycle. Those that do are called multipotent stem cells, or more commonly, adult stem cells. So for example, draw kind of a layer of skin here. And down at the bottom of your skin, you have your most vibrant and youngest cells. And as they progress towards the top, they get older, get a little more rugged. Eventually they dry out and they kind of become, well, actually they end up dying. And your top layer of skin cells are dried out, dead cells. And in fact, you're actually constantly losing those top layer. They fall off, and not to gross you out or anything, but yeah. But this is what we call dust. So most of the time when you're dusting something, furniture at home or whatever, it's dried up skin cells. So just something to think about. So that's these guys. Even on the top here, that layer of skin that you see, you can feel, you can touch. They're not surrounded by water. Cells should be surrounded by water, and these aren't. Those top layer of cells are already dead and dried up as well. I don't know if you've ever had a cut on your arm, someplace you can see it, and you can see into your skin up through that cut. And as you go kind of down through the layers, you get pinker, more juicy, more vibrant cells. You're down through a couple of layers here, and this probably isn't accurate. There's probably like 100 layers. I've only got like 5 or 6 here. In real life, it's about 100. But yeah, if you were to get cut, you can actually see kind of down into those younger layers. They're not dried out. There's water or blood. It's held in by the outer layer surrounding these guys. They're a nice color. of pink usually. They're vibrant, they're young, they're healthy, they're going. So that's these younger cells underneath. Well, at the very bottom, come over here. So you want to do something with that particular cell right there. So over here, the very bottom is your basal cell layer. And your basal cells, sorry about that, your basal cells are your adult stem skin cells. These are the ones that are going through cell division, not these guys up here, not these guys up here. In fact, this is a really cool process. So if you think about it, when a cell goes through cell division, it creates two new daughter cells, right? Two daughter cells. Well, most of the time, the camera on me here. All right. So when your basal cells divide, so again, here's your basal cells, this bottom layer of skin cells. When they divide, they're going to produce two daughter cells. One of them is a skin cell. So here's your division. It's going to produce two cells. One of them is a skin cell. It's going to start making its way up to the top of your skin. So it's going to go live its life as a skin cell. It's going to do everything a skin cell needs to do, which is basically just hold in all of your water, blood, protects you from diseases, all of that. And as it goes, kind of lives its life, it dries up and it dies. This process takes about 4 weeks. So a skin cell lives about 4 weeks on its journey from the basal level all the way up until it eventually dies. That's about the age of a skin cell. And again, it's never going to divide again. It's going to spend the rest of its life living in G0. So it moves its way up. The other cell, so the second one, the other one is a basal cell that stays in the basal layer and can divide again. So basically, when a stem cell divides, it produces one cell that lives its life, and it produces one stem cell, another stem cell. So here we are, it reproduces or renews itself. So that's what the two cells divide into. One becomes a skin cell, the other one stays as a basal stem cell. That process is called self-renewal. And it's a really important process. I mean, if you think about it, if our stem cells all divided and became two, just regular old skin cells, that's great. We'd have double the amount of skin cells and be in good shape, but we would have lost our basal layer. We'd lose our ability to make new skin cells in the future because we lost our basal stem cell. So it's a good thing that our cells do go through self-renewal. They make one cell that is now in G0. And it's going to work its way up to the top. It's going to live its life as a skin cell, and the other cell stays as a stem cell. and it can divide again when it is needed. So that's the idea of self-renewal and the idea with stem cells. Most tissues, so skin is a tissue, your liver is a tissue, muscle is a tissue. Most tissues have multipotent stem cells, like we just took a look at. Whoops, not bold, boy. Not sure where my mind is at here. So blood adult stem cells. So blood adult stem cells are called hematopoietic cells. And this is pretty cool. Blood stem cells can become any type of blood. So I know you guys know that we have red blood cells, which are different than white blood cells. Well, these hematopoietic cells can become either. This process of going through, and there's a couple of different steps that we have to go through after division, but depending on what you need, this process of either, in this case, becoming a red blood cell, in this case, becoming a white blood cell, is called differentiation or specialization. And once these cells become differentiated, they're again in the same boat. They're never going to divide again. They're not a stem cell. This is the stem cell. This is the cell that's going to stay in the cell cycle, and it's going to produce new cells that can go out and live their lives. In this case, red blood cells or white blood cells are going to go do their job. They're going to go live their life, and they'll never have to worry about dividing again. They have differentiated. And then your blood stem cells, which, by the way, live in your bone marrow, that's like the hollow, the middle part of your bone, that's where blood is made. So inside of your bones, blood is made. And again, it goes through this process of either becoming a red blood cell or a white blood cell, but it all started off as this blood stem cell, and then it got differentiated out into what its specific task was going to be. And there's a lot of different types of cells that do that. They go through specialization, differentiation to do their job. We're going to come back on that in just a minute. Big point of fact here. You hear all the time about stem cells. Some people are all for them, some people are all against them, and that, I get that. And we'll talk more about that later. But not all stem cell research is controversial. There are a lot of procedures and a lot of research that is done on adult stem cells that are not controversial at all. So I think when people say, I hate stem cell research, they really need to learn that there's different types of stem cells. The multipotent stem cells we're talking about now are not controversial. Let me give you some examples. Skin grafts, oops, a T in there. Skin grafts, that's an example of using a multipotent stem cell. When you have a severe burn or you lose some skin, they can grow new skin on there, and they use adult stem cells the basal cells we just talked about to do that. There's no controversy. We're doing that for 50 years now. Bone marrow transplants. You've probably heard of those. When you have a cancer of the blood, oftentimes it's called leukemia, and you need new blood stem cells, non-cancerous blood stem cells. So we do bone marrow transplants for a lot of leukemia patients. Guess what? You're working with adult stem cells. And again, not particularly controversial at all. So when people say they hate stem cell research or stem cell procedures, they really aren't sure that there are different types of stem cells, and not all of them are controversial. Again, we'll talk about the other types later. We're talking about why they're controversial later. But for right now, I wanted to hammer home this point, that there are a lot of stem cells out there that we use regularly, and there's no controversy at all. How about, you hear about this one all the time on commercials? Hair transplants. Again, this is widely advertised, and nobody's ever like, oh, I'm against someone having hair. Hair transplants use stem cells. So it should technically be called the like the hair root or hair stem cell transplant, not just a hair transplant. What they're doing is they're taking the cells that grow your hair and they're transporting them into your skin where you're bald. And you grow your hair back because you've got new stem cells to produce that hair there. So all of these and more are examples of multipotent stem cell research that are not controversial. So when you hear someone say, I hate stem cells and I hate stem cell research, ask them, what kind of stem cell research do you hate? Because multipotent stem cell research and procedures, not controversial at all, really. All right, one final thing, we're going to kind of go back to differentiation and specialization. And this is actually going to kind of wrap up our chapter, bring us back around to where we started. All right, so we started the semester with that activity. We just built the cubes. And one big reason that cells stay small is the surface area to volume ratio. That's a huge, huge reason. You have to have enough surface area to bring nutrients into the cell. So you really just couldn't get a large cell. But another big reason that cells stay small is cell specialization. Instead of having one gigantic cell that has to do everything, it has to make energy, it has to convert energy, it has to work as a muscle, it has to move you around, it has to do the thinking, it has to do everything. Instead, we can go through cell specialization. We can say, hey, you million cells over there, you guys are in charge of breaking down the food. You are now the stomach. You million cells over there, you guys are now all blood cells. Please carry oxygen to the rest of the body. And we can specialize these cells. So going back up here, we can make these cells very, very specific. They don't need all the organelles. They don't need to be able to do a million different things. And that's one big advantage that we have over prokaryotes. Prokaryotes, one cell has to do everything. So it has to have, everything that cell needs to stay alive. Our cells don't. Red blood cells don't even have a nucleus. They don't need one. It just kind of gets in the way. All they need to do is be able to carry oxygen, and that nucleus is just going to get in the way. So two big reasons that our cells are small. One, yeah, they physically have to be, the surface area to volume ratio, but another reason is cell specialization. We can have a whole bunch of little tiny cells that only have to focus on one area. That's specialization. Those cells can become very specialized at what they do. They don't have to worry about getting oxygen. It's going to be brought to them. They don't have to worry about getting food. It's going to be brought to them. That sugar doesn't need to be broken down. They're going to be given glucose directly. They don't have to worry about breaking it down, any of that. They just have to do the basics and then get very specialized, very good at doing their specific task. All right, so like I said, we kind of came full circle here. I kind of talked about what we started with, why are cells so small? There they are. Talked about some stem cell research, did some cancer earlier, and that's the end of the unit. That's all the notes. There should be a test review up online, so take a look when you have the chance, and I'll see you guys next time.